So I just have another example here so that you can see it. If you wanted to find the minors, you just basically look at ignoring the rows and the columns and find the determinant of those. So for example, I'll just give you a couple. So in the first row, first column, you'd have -3 plus 45. If I skip to this entry down here, ignoring this row and this column, -18 minus 28. I don't guarantee that every answer is perfectly right. I'm assuming most of that it is, but this is just an example for you to try. So now let's get to the why you would ever do this. By being able to find the cofactor matrix, you're able to find the determinant of any matrix if you follow this formula by just basically taking the entry in whatever row or whatever column you would like times the cofactor matrix or cofactor value of that entry. And all you need to do is follow along one row or one column. Just look at this, pick whatever row you want and continue the process, or pick whatever column you want and continue the process. So I'll just pick a different value just so that you can kind of see how it works. I'm going to just focus on this column here, 6, 1, 5. What this is saying is I can take 6 times the cofactor value of what's left. So -12 minus 18. Once again, -12 minus a minus a minus 18. So -12 minus 18 is -30. Then I have +1. Ignoring the rows and the columns would be -6 plus 14. And the 5 that I have here, ignoring these rows and columns, would use these two, -9, 7, and -4. So -18. -18 minus 28, once again, is at -46. But before you say that's the answer, you have to double check that you're in rows or columns that are odd or even. So this value is going to switch to an opposite, as this one will not, because it has an even number of rows and columns added together. But once again, this 5 will as well. So if you just kind of follow the logic there of you have to be careful about your positives and negatives, you'd have your values. So the value of this determinant in this case is 180 plus 8 plus, what is that, 230 put together is 418. And it doesn't matter which rows or which columns you use, this will always work. That's not the only way to do a matrix. There are some shortcuts. So for example, for a 3x3 and for only a 3x3, remember how you could find the determinant. You could take 2 times the value of that minor, the determinant of that minor. I did the opposite of -1 because it's an odd rows and columns added together. The determinant of that minor plus 8, determinant of the minor. If you put all those calculations together, you'd get your answer. What they found is that you could also take and expand those rows and columns like I have here. So I just took the original matrix and then just kept repeating the values of the columns, like it just kept going. I just took that value and moved it over here. And what they found is that you could take all of the values along the main diagonals going from upper left to bottom right and add. So I'll just show one of them. Like when you go this way, you would add. And then when you go the other direction, you would subtract. So you're basically going to go through the entire matrix 3 times. You don't wrap around like Pac-Man. You just 2 times -3 times -5 plus -1 times 7 times 6 plus 8 times 5 times -4. When you go the other direction, you subtract them all. If you're wondering, that seems kind of arbitrary, or why would that work? Just look at your values. Every value that you find below from this shortcut, so to speak, you'll find somewhere from doing it the long way. It doesn't matter which one you're looking for. You'll find it somewhere earlier in their calculations. Once again, this will work only for a 2x2 or a 3x3 matrix. It will not work in a 4x4. What you're going to notice when you're finding a determinant is that at times it's easier to pick certain rows and columns than others. So in this case, it would be better for us to pick something like, I'm going to find the determinant from this column or this row because it includes the 0 as one of the entries. And that makes it so that one of your one of your calculations with minors is only going to be times or multiplied times a 0, instead of picking something that has all 3 entries. So I'm just going to show this to you with the first column. So in this case, I want to take 3 times the minor that's here, or the cofactor. So I'm just going to show you what's going on with this the first time. I don't need to do any switching of values because that's in that first row, first column, an even number. I'm going to take that and add it to actually subtract 6 times the minor of the determinant of the minor, excuse me. And then I have 0, and what's there really doesn't matter. I would have, what, -5, 1, -2, and 4. Technically, the negative would affect this, or the negative would not affect that. I take that back. So now I have one easy calculation and a third of my work is done. So when I figure this answer out, I really only have to do 2 strands of work instead of 3. 18 minus 28. 18 minus 28 is -10. -45 minus 7. -45 minus 7 is -52. If I put this together, I have what? -30 plus 312, which gives me 282 as my answer. And it doesn't really matter what row or what column that you use. That would be the key idea of this lesson.